Hi, I wanted to take a little bit more time to introduce myself if you weren't in class on Wednesday. My name is Rianne. I am a senior here at U of A and I'm studying physics. And this semester I will be working closely with Sam and I will be helping you learn the math skills that you need to be successful in this class, and also using some problem-solving skills that I've developed along the way personally as a physics student, and kind of sharing my knowledge with you to help you be successful in this class. The reasoning behind this is a lot of students have a very hard time in this class, and usually it is not because of the physics. Usually it is because of the math. It kind of comes out of nowhere, and so Sam and I both agree that we would rather you guys get stuck on the physics part of things rather than some calculus that you can definitely learn. So that was the motivation behind these videos that I will be making. I also wanted to take a little bit of time and talk about how these videos will be working. So I will be uploading 1 to 2 videos about weekly, and the first video will be exclusively math oriented. So it will just be the math side of things, what you need to know, how to solve these types of math problems. And then in our second video, I will be solving a physics problem using the math that we learned in the first video. Both of these, I will be going into excruciating detail about everything that you need to know about each aspect of it. So the actual math side of things in excruciating detail, as well as the physics problem-solving aspects in excruciating detail. Just a reminder, these videos are going to be 3% of your grade. However, it's not going to be based on your correctness or anything along those lines. It is just purely participation. On top of that, I will be holding office hours of my own. I announced those in an email, but to announce them on here so you can write that down or whatever, it's going to be Wednesdays from 4 to 5 p.m. and Thursdays from 12:30 to 1:30 p.m. And they're both going to be in PHYS 170C, which is where your discussion section was for 141. If you took it last semester or any semester before, that's where your discussion section is. If you don't know where it is, it's on the basement in PHYS on the north side of the building. The next thing I wanted to do was to kind of kickstart our time together, talking about how do you start solving a physics problem. I know since I was an SI leader last semester, a lot of students who came to me were having troubles just starting the problem and kind of what to do when you start the problem. And so I came up with this document last semester, but I reworked it for this semester for E&M. And I wanted to share it with you guys, and I'm just going to be going through it, and I'll upload it onto D2L when this comes out as well. So I wanted to go through it, and I'll have some questions throughout just to see if you're paying attention, basically. So I call this Rianne's Tips, Tricks, and Algorithm for Solving Physics Problems, E&M edition. So this will be up on D12, like I said before. So our first step is to read the problem, which obviously seems a little dumb, seems a little silly, but seriously, you should read it until you can visualize what's going on inside your head. And then I personally like to underline buzzwords. And I started doing this with my students last semester in 141 for my SI sessions. And it really helped them kind of make it into a game. And that's how I want you guys to view these problems, is to go about this as a game. So some buzzwords that I can think of are some spontaneously, it's constant, uniform, tangential, initially, it encounters, it's a closed path, circular, it's negligible, the cross section, the origin, anything along those lines that describe what's physically going on in the problem are things that you want to underline so that you can visualize it inside your head of what's going on. Next, what you're going to want to do is you want to draw a picture. Obviously, you don't have to be an artist, but the most important thing is that you understand what's going on and your grader, who's going to be grading your exam, knows what's going on. Is it clear enough to show what's going on inside the problem? And then the next thing you want to do is draw a force diagram. This is something that you're still going to be doing in 241, so you don't want to get rid of it so fast. And there is a difference between these two, right? So in your picture, you can include anything you want. That means any a coordinate system. It can include any motion variables like velocity or anything along those lines, field lines, field directions, and anything along those lines. And then for your force diagram, you only want to have forces acting on the object or objects. You want to have a coordinate system in there too, so you can keep track of it, but also each scenario needs to have its own force diagram. Whereas in the picture, you can kind of get away with having an initial and final in your same picture, if that makes sense. And some things you want to ask yourself when you're making these pictures and making these force diagrams is, how is the motion changing from start to end? Your initial and final conditions. How are the fields changing? What objects are being used? Is there a conductor, a capacitor? Are they just point charges? What's going on inside the problem? Is there anything hindering the motion or hindering the electric field, hindering the magnetic field, anything along those lines? What forces are going on? Anything along those lines that could help you understand what the motion is doing, that can help you lead to a force diagram. Third thing you want to do is kind of decide what kind of problem it is. So how are the objects moving and why are the objects moving? Why is there an electric field? How is there an electric field? Anything along those lines. You would kind of add on these electric and magnetic things from our 141 discussion about motion, but the premise is the same. How and why are these things happening? Is anything conserved? Go back to your buzzwords that you underlined. Do any of those imply that there are quantities that are being conserved? Last thing, most of the time there are multiple ways to solve a problem. The most important thing to remember is to pick the solution and pick the way to solve it that makes most sense to you. Fourth thing, you want to write down what you know, what you don't know, and what you're solving for. Just because the problem doesn't have a numerical value for a variable doesn't mean that it's unknown. What do I mean by that? Let's say you have a circle and they say that this circle has a radius r. They may ask for an actual numerical value at some point, but for right now, your given value is r, and it is given to you, and it's not an unknown quantity. The next thing is you want to break down into small parts. So you want to make sure that when you're setting up what you know, what you don't know, and what you're solving for, that you can have bite-sized pieces of what you're solving for. Your next step is to find the equations that you need. You want to break down these equations into components if it's necessary, and you want to break things down into steps. So for example, using a 141 example, let's say you're trying to solve for the final velocity, but you need the time to solve for the final velocity. So you're like, okay, I'm going to solve for time first, and then I'm going to solve for final velocity. This is going to be the same premise in 241. And lastly, you do not want to plug in your values until the very end. So if you are given numerical values, you want to wait until you've solved it algebraically, and wait until you've solved it algebraically to put in your numerical values. Lastly, your next step is to plug in your numerical values if it's necessary, and then circle your answer. Another tips and tricks for this is to make sure that your calculator is in the right mode, whether that's radians or degrees. And also, when you are entering things into your calculator, break things down into smaller bite-sized pieces rather than just putting the whole equation into your calculator and then hitting enter, because most of the time it doesn't work. I hope you guys found that helpful. I will upload this onto D2L, and I hope you guys have a great rest of your day. I'll see you soon.